Creating a first building with ARCHITECHTURES. We will continue with the practical example from the previous video. Remember that we are in Plan View mode, at the root or site level, and in Auto Editing mode. The tabs of the input panel that we will address in this video are also displayed at the building and floor level, thus allowing us to subsequently edit our designs from different scales. First, we find a set of 5 tabs called Net Area in, where criteria for design and target surfaces for different spaces and types of units, from studios to 4 bedrooms, are collected. This time, we will modify some aspects of the 2-bedroom apartments. In the Design Criteria section, we will activate the option for the dressing room and allow interior kitchens. We will assume the default surface areas. In the Internal Minimum Dimensions tab, we locate the normative requirements that the project must meet at a geometric level. It should be noted that these requirements take precedence over those for net area. In case of a conflict between them, the room will be dimensioned to meet the minimum required dimension. This time, we will increase the minimum width of the master bedroom to 3 meters and the minimum width of the main bathroom to 1.7 meters. The next tab is called Construction Parameters. Here, globally for the building, the thickness of the construction elements, both vertical and horizontal surfaces, as well as the distribution and configuration of structural pillars and ventilation ducts, are defined. The configuration of this section has a dramatic impact on surface calculations and efficiency ratios. Therefore, it is recommended to configure it before or immediately after creating the building. It is also very useful for configuring our BIM model so that it is easy for us to progress towards a higher definition. This time, we will modify the default values of the structural span to force it to be 8 meters on the x-axis. Next, we find the General Floor Design tab. This section is very relevant because it allows us to configure aspects of building typology such as building type, core position, or corridor ends, as well as aspects about building sizing, such as building width, number of typical floors, heights of ground floors, upper floors, or elevator shaft, or the inclusion or not of an penthouse floor. For our project, we will ensure that we have a central corridor typology, with a width of 17 meters, position of the core at the back, a penthouse floor, and a 2-meter height for the elevator shaft. In the Housing Mix tab, the distribution of the objective housing for the typical floors is set. Depending on the typology, from studio to 4 bedrooms, through the target percentage distribution. The AI will try to adhere as closely as possible to this percentage distribution within the limitations imposed by the geometry. This is an interactive process that can be adjusted quickly by seeing the results we are obtaining. On the other hand, typically, different distributions occur on the ground and attic floors than on the typical floor due to the particular characteristics of each one, so we must adjust the distribution on the typical floor considering the variations that occur on other floors. This time, we are interested in obtaining 30% of the 3-bedroom apartments and 70% of 2-bedroom apartments. Next, we find the Common Areas Sizing tab. This contains configuration options for common area spaces, vertical cores, stairs, and elevators. Specifically, aspects such as the number of elevators, stairway zoning, or whether split landings are allowed, minimum widths of common corridors or access portals to the building, the width of staircase flights, the width and length of the elevator shaft, etc. For this project, we will increase the number of elevators per core to 2. In the next tab, Terraces General Floor, we find different configuration options, such as minimum width of passage to exterior terrace, minimum terrace width, or dimension of the overhang. We can also activate or deactivate the existence of terraces for each of the building's facades. This time, we will increase the diversity of terrace placement on the facade and the dimension of the overhang, so they will not all be aligned with each other. Finally, we find the Facade Parameters tab, where we globally define for the building the size of the openings according to the room they are in. This is done by configuring 2 elements per room, the sill height and the window width. This can be useful to ensure compliance with certain regulatory requirements, particularly lighting and ventilation requirements. This time, we will increase the sill heights in kitchens and bathrooms to 0.60 meters. Once our project is fully configured, we proceed to insert the building. As we have seen before, simply press the building button and draw the polyline that will act as its axis. Once the building is processed, the data panel will be activated automatically, and the 3D model will be generated. In Plan View mode, at the ground floor level, and in Auto Editing mode, we find the garden's width on ground floors. This is similar to the terrace section on the typical floor but simplified. It allows dimensioning and enabling or disabling the gardens of the ground floor residences. For this project, we will deactivate all of them. In Plan View mode, at the penthouse floor level, and in Auto Editing mode, we find the following tabs. Housing Mix Penthouse Floor. Similar to the Housing Program section on the typical floor, it allows us to control the distribution of housing on the penthouse floor. This time, we will indicate 50% of 2-bedroom apartments and the other 50% of 1-bedroom apartments. Penthouse Floor Setbacks allows independent control by facade of the setbacks that the attic floor must have with respect to the typical floors. This time, we will only maintain the front setback. And finally, terraces on the penthouse floor, similar to the typical floor section. This time, we will deactivate all of them. Similar to what happens with the tabs of the input panel, where some appear only at a certain scale or visualization level, it occurs in the data panel. Also, any parameter we modify will be reflected in this panel automatically. We can identify the Budget Summary tab that appears transversely, at all levels and visualization modes we find ourselves in. This tab shows the breakdown of the budget with the main concepts and the most relevant ratios, being able to have this information without changing the visualization mode. On the other hand, in Plan View mode, we can identify two types of tabs that adapt their content based on the level we are in. The Plot or Building Area Schedule, which includes our objectives for the project, a breakdown of the main surfaces, and the efficiency ratio. And the Housing Mix in Plot or Building, which includes the distribution of units and an average of the most important surfaces and ratios by residential typology. In addition to the above, in Plan View mode, at the root or site level, regardless of whether we are above or below grade level, we find the below grade areas and ratios, which shows the surfaces, units, and ratios per dwelling of parking spaces and storage rooms. In Plan View mode or model, at the plot, floor, or unit level, we find the typologies in floor, which consists of a list of all the typologies present on the selected floor with their surfaces and most relevant ratios. And finally, in Plan View mode, at the unit level, we find the areas unit, which includes a breakdown of unit surfaces and the difference between these and the target surfaces. We encourage you to continue watching the next video to learn more about our platform.